All right, so welcome everyone. Um, I I don't have much content to show today. Let me just share my screen. Are you guys seeing my screen right now? I wanted
Yes, I
this
see.
cool. Cool. Yeah, I wanted this to be mostly Q&A for the final project since this is going to be our last meetup before we're presenting. And and I just had sort of some quick summary, kind of summary material to go through. So what I'll do is and for assignment six, since assignment six was different for everyone, there's not much to go over for that assignment. So I'll I'll just go over what I have, and then we'll spend the rest of the time answering any questions. Since we're a fairly small group tonight, like we'll just hopefully if you guys have any kind of particular questions, we could dive into those and take advantage of the smaller number of people here. Cool. So with that, let me just get started. So what I wanted to do is just kind of summarize a lot of what we've gone through and focus more heavily on kind of what steps I would recommend taking next to continue learning more about data visualization, about different packages that are out there, and just kind of next steps after a course like this. So just to kind of start out, a common theme that I've been talking about throughout the course is, data visualization really being the intersection between data science and web development. Obviously, with what we've covered, that should be very apparent in how we've kind of gone through the material of the course. And I just wanted to add also that currently as its own as its own sort of segment, as its own kind of field, it's data visualization I would consider as being underrated in the industry so far, but it's something that I've just in my experience I've seen only growing over time. So it's something that I think is going to mature. A few examples I've listed here being Capital One has been one of the first companies I've come across that have actually started their own devoted data visualization practice. They actually not recently anymore. I think it's been been like a little less than a year. They've hired a data visualization VP, and really turned that into a major practice of theirs. And they, it's similar to kind of the way I've been trying to focus the course. The way that they're thinking of it is they have these reporting requirements there, and this team is kind of meant to really be that front end link to their data engineers. They have their data engineering team, they have a team of data scientists, and a lot of it's actually becoming pretty common now that you'll see a lot of companies beginning to kind of diversify their, like, rather than just having a single data science practice, sort of dividing up those roles into multiple fields. And Capital One has really been kind of the first instance I've seen where there's sort of a specific data visualization practice. But that is something that's slowly becoming adopted elsewhere. Just to kind of mention that, and then I went through this already, but IBM is sort of the example I'm bringing up here. of the kind of division of data science practices into complementary skills. There's, they sort of, and this is more common. That's just sort of the first parent example I've really kind of thought of, where they, specifically have a data science practice, and they specifically sort of divide that into different complementary skills. So they have, sort of the data engineering side. They have the more statistics oriented, data science side. And then they also have a specific data visualization side, which is more the front end of all of this. So, basically, in terms of next steps, like what kinds of libraries to, look at, both in terms of just, any projects that you may be working on, or, if, or potentially for your final project, if like some of these are a bit more kind of beyond the scope of the course, but for some, it might be useful for your final project if there's still, if you're still sort of working out some of the details there. So on the web development side, we went through Flask, and that's out of sort of more back end frameworks. Flask is the two major frameworks in Python. You have Flask, and you have Django. Flask is a bit more lightweight, so we've really only brushed the surface of Flask, and it's something that as you're working, as you're sort of working deeper in this field, that would be something to dig into more on the back end. And then something that we haven't touched on at all, which is React. That's sort of a way of another way of sort of looking at the front end. It's one of the more popular libraries out there now, one of the more recently popular, and it's really based around sort of modular front end work. So having being able to it's actually very similar to what you would see with something like Dash, where you have and there's no surprise there since Dash is based off of React. You have React components, you have inputs being accepted and being able to re-render the components. React obviously being more fundamental than something like Dash. You have just more options in terms of things like managing state or more complex problems that you may come across with web development. And there's and recently, D3, a lot of older examples you'll see sort of more standalone, but I've been finding sort of as time goes on, and especially as React has been gaining more popularity, there's been more kind of work done with D3 and React together. So that's also something to watch out for there. And then these libraries that I'm mentioning here, I mentioned them just because it's more so it's more of the logical next step after something like D3. And something like Crossfilter is, I believe I mentioned this in a previous meetup, that Crossfilter is just conceptually, it's really referring to the style of being able to filter using the graphs themselves. So you could kind of see how things work doing something like this using this is using a flights database. So you could see sort of slice and dice the data visually in this way. And in Dash, cross filtering is really what we refer to with any sort of chart input and sort of registering that as an output for other elements of an app that you're building. And DCJS is a library that is meant to really bring these two together. So this this sort of this kind of library is, if you are working more heavily in JavaScript, something that really sort of uses cross filter to mimic the conception of data frames. Like there's if you sort of delve into the reference here, you'll see that the actual objects that you're working with, it's it's not as well developed as something like Python or R, where you have actual data frames. But with these sort of JSON-like objects, you're able to perform operations that you would be performing, pretty easily with data frames. You're filtering stuff like that. So cross filtering is sort of getting JavaScript in that direction slightly, but it's there's still nothing that at the moment in JavaScript that would beat what you're able to do with Pandas or R data frames. And then moving on from that, in terms of just higher level contextual, sort of more conceptual matters, the here I sort of wanted to, kind of recharacterize a theme that we've come across a bit in the course, but never really talked about directly. And the way that I'm framing this is sort of looking at a data visualization project as either something that's static or what I'm calling iterative. And what I mean by that is we touched on this a bit when we were working on assignment 1, where we, so something, and actually before I get into that, something that's static, you're able to really polish your user, your visualization, your, document, whatever sort of static app you're working with. You're really able to polish it to aim to to get the best user experience. So one of the kind of best examples of this is what you would call sort of infographics. And these sorts of data products, they're they're usually static, they're usually highly styled as a result of that. And it's meant to be sort of a one-time get your point across and really tailor the experience to the data that you have. Whereas something that's iterative, and you could see this as iterative in multiple ways. It could be iterative either as sort of a dynamic, data-driven app where a user is making selections and you're changing the output as a result. Or it could be iterative as in a sort of something that is less interactive, but is being fed with live data or being fed with more unpredictable data. The data underlying it could change, and the sort of product itself is like needs to be able to deal with multiple types of data, or not multiple types of data, but multiple sort of dealing with the same type of data, but at different times or in different, different categories. And something iterative, you're really focusing more on what will fit, sort of the, sort of data that it could expect. So if you're building an interactive app, that's sort of the thought of edge cases and, really making sure that if it's working for one view, it's going to work for another view. With live data, there's, the sort of making sure that no matter, kind of getting an idea of what is the range of data and, what's the best way to deal with, high traffic days, low traffic days, high variation, low variation, and still be able to show a particular, be able to show the insight that you're looking to get across. And to relate this to what we've worked with in our course, for assignment one, we part of the assignment was labeling outliers, and that fits more with the kind of static framework, side of the framework here, where you you have a certain quality, you have your data. There's the data is not going to change, and you therefore have more freedom in terms of labeling outliers. Whereas if the data were changing, and a lot of students ended up coming up with different unique ways of dealing with outliers, things like log scales, for example. That's a good automatic way of dealing with it. And of course, there's always algorithmic ways that you could deal with outliers. But that's sort of more what you would be thinking of on the iterative side. So this is something that I would like everyone to kind of think of for their final projects. Think about what you're sort of aiming for with your app, and try to basically style it as much as you can, with the sort of thought that if it's fully static, you could style it however you want. If it's more iterative, then you need to think about different edge cases. If it's interactive, or for final projects, it's mostly going to be sort of those questions of interactivity. And then to kind of just touch again on when we were dealing with big data, there's the context again matters, and we've sort of tried a couple of different ways of dealing with a larger data set. Datashader is great with just taking whatever you throw at it, but it's also it's helpful to keep in mind the manual aggregation exercises, as well as a few of the points that sort of styling points that we were talking about previously, where if in the previous slide, where if you have something, if you are dealing with outliers as an example, and you're dealing with a large data set, the question may not be what the sort of way that users may want to interact with the data is having your sort of general pattern where you're not too worried about individual points, and then sort of highlighting extremes, highlighting outliers, being able to kind of combine the general shape of the data with the kind of pointed outliers. Then just kind of a quick take on sort of different like using AI and data visualization. It's this is something that has been evolving more recently, and it's something that in general it's a bit overrated. I've a lot of times the goal of something of this sort of merging of AI and data visualization is thought of as using essentially having a chatbot being able to essentially ask ill-formed questions and be able to get a sort of the dashboard that you're that really you're expecting. Whereas now, anyone who's creating data products for sort of consumption, there's a lot of thought into that goes into the design of these products, and a lot of times it's not full. There's partial, like part of that design is trying to accommodate like what sorts of questions would someone ask, what sorts of and really anticipating what they're not asking, and including that in your visualization and making that part of really how you're getting your point across. So it's something that it won't be magic, but it will be something that as as it evolves, it'll be more sort of the kind of combination of human data scientist and AI, and really focusing on more narrowly defined tasks. So, sort of the example I give where it's like a very pointed question, being able to, sort of highlight and not coming up with a specific, one answer, but more framing, a view of the data that would match, sort of a question of this sort. And then lastly, just kind of, talking about some, general themes about how data visualization fits into, data science in general. I sort of mentioned this earlier with kind of in an earlier slide where, it's where data science kind of came about with the need to try to group together a lot of these, formerly disparate fields, and trying to really like keep all of that, sort of try to teach, sort of have generalists that are able to, do all of these things very well. And it's, as I also mentioned, it's something that, it's hard to have it all, as I put here. And there's there is sort of a move more towards kind of, breaking things apart, like having teams that are, specialized and are working together to, really bring together all of these fields. But what I also think is, more important when thinking of kind of the various parts of data science that could, could be brought together, is thinking of it as more kind of a blurring of lines between various skills. And in particular, what's called here hacking skills, the kind of data engineering, computer science side of things, that's something that is being more democratized as time goes on. And there's so there's like the barrier of entry for tools like Jupyter, RStudio, that's going to sort of continue to get lower and lower. Anyone who sort of has worked with these tools for a longer period of time before they've kind of reached the level of maturity that they're at today. Like personally, in working with RStudio, I sort of started learning R before tools like dplyr really gained traction. And even just a library like that has really and even now, like I'm way more focused on Python professionally, but the whole sort of evolution of the Hadleyverse, that's continuing to really make these tools way more accessible to to kind of people who previously would be afraid of more daunted by learning a programming language. And sort of on the other side, you have a lot of people with more either subject matter expertise or kind of the more general math and statistics background. On the statistics side, thinking of tools like Stata or SPSS, and on the subject matter side, a lot of different industries have their own specialty tools. Me coming from an economics background, I've worked with eViews, and a lot of these tools, it's if you really take a step back and think about what you're doing, it's you're basically programming. You're just using a framework that's very specific to what you're doing. And as this is filtering into R and Python, these a lot of these tools will sort of more people will sort of move into the environments like Jupyter, environments like RStudio. And I bring this up because this is actually from a talk by Fernando Perez, the founder of Jupyter, the creator of Jupyter. And he also teaches at UC Berkeley, and he's developing courses for their data science department. And this is an example of a course that is part of the core curriculum for all students, and it's I think the stat he mentioned was pretty much half of students in enrolled in UC Berkeley are taking this course, and it's and you could see from sort of the screen grab from the picture of the lecture hall, this course is using Jupyter. They do it in a more kind of, they sort of have their own Jupyter Hub environment. So students are just accessing Jupyter from a site. They're not running it themselves. So, there's sort of a bit of curation that's going on there, but it's still, in my opinion, a pretty big deal that you have, that percentage of students from all departments taking a course like this. So, as time goes on, simply saying, Jupyter, tools like this, that's, not going to be as big the differentiator as it has been before. But, what will matter is you have this background and you're combining that with your subject matter expertise. So there's always, there's always going to be sort of more, advanced engineers, more, kind of the computer science track. But, this is just kind of a lot of, there is going to be sort of a, sort of separate level of this more democratized, sort of way of using tools like Python or R. Um, so that's all for the content. And then just one question before I sort of open things up. In terms of getting back to kind of, different libraries that that sort of I listed as things to look at for next steps for those interested in digging deeper. Um, in terms of what you guys are working on with your final projects, are there any libraries that you're using that you might want to share with everyone else on the call? Folium. June mentioned Folium. Is that I believe that's based off of Leaflet, right? That's like tile maps. Yeah, I think it's a Python wrapper for Leaflet. Yeah, yeah, and then Alvaro using Leaflet. I didn't mention mapping packages, but there's um, a lot of those out there. There's uh, there's libraries that are sort of more focused on larger on kind of larger data sets in different ways, like Datashader we went through, but there's also Vue.js, which is or Vue.gl rather, which is taking another approach, sort of using the computer's graphics card, using what's called WebGL to render visualization. Anything else that anyone else on the call is using? Cool. Nothing Viz related. Cool. So yeah, I purposefully wanted to, leave the content fairly short, and since assignment 6 was specific to everyone, there's not much to go over there. But so sort of with the last, bit of the call, I'd like to open it up for any questions you guys have on the final project. We're really in the final stretch now, so everything that you guys are doing should be devoted to the final project. So any questions that you guys have? And actually, if anyone's typing, one more thing I forgot to mention, during our previous section, I had posed it to the class, asking about how how we're going to be sort of scheduling everyone. And so, you know, I'd like to aim to have to have all of the presentations be, 5 to 10 minutes, be pretty short. We do have a lot of students, and as for I think everyone here, this isn't your first class, so so there's a tendency for these to sometimes run long, and unfortunately, that's how it works. But luckily, they're always really interesting, at least with from what I've seen. So, and this semester, from everyone's proposals, like it should be a pretty good night. And what I'll do is I'll create a either shared spreadsheet or another way of kind of um, scheduling everyone, and I'll sort of have everyone kind of enter in a rough kind of timeline of when they're planning on presenting, and then for presentation day, I'm combining the two meetups. So essentially, we'll just have one long meetup starting at 6:30 and ending whenever everyone's finished. So if you would like to present early, like I know a lot of people have been kind of going back and forth between the meetups. So if if you would rather go earlier, definitely sign up for some of those early time slots if you want, and we'll try to schedule it that way. Any other questions on any other questions on the finals or on the rest of the course? Cool. So yeah, if there's no more questions, I'll just let us end early here. In 2 weeks, we'll have our final project presentations and look forward to an announcement. I'll post the scheduling, and good luck from what I've seen in the proposals. It should be a pretty good batch of projects. So good luck, and email me if anyone has any questions. All right. Thanks a lot, everyone. Have a good night.
Thank you.